um, that should actually finish up the lessons for Unit 4, and then we're going to be on to the test. So the equation of a circle given its center and radius. Write the equation of a circle given its center and another point on the circle. Sketch a circle given its equation and find the intercepts of a circle. So as you can tell, we're talking a lot about circles. Gotcha, Stephanie. Gotcha. Well, I guess it's not going to kill you to take it, right? But I understand where you're coming from. All right, so here's the equation of a circle. Yeah, it might, huh? Oh, that's funny. Hey, there we go, Delia. I like that. There's a sketch of a circle. You just typed it in the chat. And oh, yes. So this equation is the equation of a circle. I know it looks a little bit scary, but it's really not as bad as it looks, I promise. What all these letters represent are things on the circle. So the H and the K in the formula, so you'll see here there's an H and a K, they represent the coordinate of the center of the circle. So this is the X value of that point, this is the Y value of that point. Okay, so it's just an X and a Y value of the center of the circle. And then the X and the Y represent a point on the edge of the circle. Now, when we write the equation of the circle, we will keep X as X and Y as Y. But just so you understand what those represent, they allow you to find any point on the circle. So if you needed to, so just like we sketch a line, okay, so think about back to the equation of a line. You guys hopefully remember that, y equals mx plus b. We would write, you know, y equals 3x minus 4. Okay, we'd fill in, good, Nora's giving me a smiley face. She remembers that, that's awesome. And what that did was that allowed us, if we wanted to, we could pick an x value and plug it into that formula and find the y value, and then that would give us a point on the line. Well, it's the same idea here. If we have an equation of a circle, we will have H filled in, K filled in, and R filled in, and I'll circle those just so that you guys can see that. These are going to, okay, the ones I'm circling in purple, you're going to have numbers filled in for those letters, okay? The X and the Y will stay as X and Y, but what that's going to do is it's going to allow you to put in an X value if you want to and find the corresponding Y value so that you could find a point on the circle, okay? It's just describing, because remember the circle, now remember one of the common misconceptions is that a circle is all the points inside in here, and that's not the case. A circle is just the point on the edge of the circle, so all these points around here make up the circle. So this just describes how you could find any of the points that you might pick here, okay? Good, yeah, well that's a good plan too, Tristan. Although, so yeah, go ahead. Tristan's talking about college again, which is awesome. I love that we're having these conversations. He's saying his plans to find a good job without needing to go to college so he can avoid loans, which is good. Now, definitely, like I had a friend that went to an Ivy League school to become a teacher, and so I guess my other tip to you guys is think of college as an investment. You definitely don't want to take out a bunch of loans that you're not going to be able to pay back. Now, if you're going to become a doctor and you have to take out a loan, then that's probably going to make sense. But yeah, that's great that you're thinking along those lines, Tristan, because yeah, I mean, if you get, you know, if the reward or the return on your investment's worth it and you're able to pay those loans off quickly, then it's not going to be a big deal. But yeah, it depends on what you want to do. So you got to think of it in terms of that. A lot of students say, oh, I'm going to go to college and party. You know, that's always the a common theme you hear. But to me, that's one expensive party. I would rather just take my money and go tour Europe or something and then come back and go to college and actually get serious. So that's something to think about there. Because college truly, I know it's hard because, you know, you're just in that stage of life where you're not ready to sometimes think seriously about what you're going to do, but it really is an investment. You want to treat it like an investment and use it wisely. So, my 2 cents. All right. We really got off topic on the equation of a circle, but that is true, Ben. That is true. It is more work and more homework, but just think of it as you're working toward your career. I know, it's work. It just never ends, does it? I hear ya. All right. So again, just reiterating the equation of a circle. Like we already talked about, the center of the circle is at H and K. So if we take a look at this equation right here, you'll notice now we have values filled in for H, K, and R. If the directions had said find the center and radius and graph this circle, we could do that based off of this equation right here. The center of the circle would be at HK, which is 3, 1. Now one thing you're going to want to watch on the equation is notice that these are subtraction signs here. And in this case, there are subtraction signs there, and so you can just take 3 and 1. However, if this was a plus 3, okay, so if this sign here was plus 3, the x value of the center would be negative 3. Okay, or if this was a plus 1, okay, in other words, and I think I have another slide where we talk about this, but let's say if we had x plus 3 squared plus y plus 1 squared equals 16, how you could rewrite that in terms of a minus sign would be x minus negative 3, right? A plus is really the same thing as a double negative. Do you remember that from algebra? Okay, Nora does. She's always remembering everything. Awesome, good, okay. Tristan, Aspen, Ben, they all remember that. So then this would be, because there's a subtraction sign there, the negative 3 would be your x value. And then negative 1 would be the y value. So the center of the circle in that case would be negative 3, negative 1. Okay, so that is one place you just want to watch and make sure that you have subtraction signs in your equation, or if they're written as plus, you can rewrite it as a double negative just so you don't miss that negative sign, okay? So just remember, if it's a plus, you can write it as a double negative, and then the negative number is what you would take, okay? Also, another tricky part about the formula is that this number over here is not just r, it's r squared, okay? So like I pointed out here, 16 is r squared, so r, the radius, is actually 4. Okay, 4 times 4 is 16. So just two little things to watch out for there that will mess you up. First one being the signs here, and then second one is, remember, you take the square root of that number. Okay, other than that, it's not too bad. You just have to remember those two little things to watch for. So in this equation here, the center would be 3, 1, and the radius would be 4. And if we know those two things, we can graph the circle. The first thing you would do is graph that point. So notice here we graphed the point 3, 1. And then you can just count horizontally and vertically 4. Okay. Now you're not going to be able to go diagonally and count because the tick marks don't go diagonally. So go horizontally. And we can see here if I start, I go 1, 2, 3, 4. Okay, so the radius would be 4. And you just do that in each direction, and you'll be able to connect those and make your circle. Does that make sense? How you would be able to graph that circle based off of the center and the radius? Do you guys see how you would be able to graph 4 points, the center, and then 4 points on the edge of the circle, and then connect those in a circle. Okay. Good, 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 good. That's what I want to see. All right, so now let's do the opposite. Let's see if you guys can do this. I want to give you a minute to look at it. The question here is the opposite of what we just did. So in this case, we have the equation, and it's asking you, or we have the graph, excuse me, and it's asking you to write the equation. Okay, so here's the information that you'll need. So give it a shot. What you're going to want to get from this graph right here are two things, the center and the radius of the circle. Okay, and now this actually does pass through that point right there. I know there's a tiny little gap, but let's just say that it's actually going to pass through this point. We'll make our circle a little bit wider right there. Okay, so it's going to pass through this point, this point, this point, and this point. Okay? Okay, good. Let's see. Will said x minus 1 squared plus y plus 3 squared equals 16. Okay. Good. So let me give you guys a minute and let me know if you guys agree with Will or if you think it's something different. And then Ben agrees and Tristan agrees. Tristan, would you mind showing us on the board how you got that? Stephanie agrees with Will, or Stephanie, would you mind showing us? Anybody want to jump on the whiteboard? I would love that. Don't be shy. Yusuf agrees. Awesome, Tristan. Thank you. I'll give you whiteboard privilege. Okay, so show us how you would arrive at that, Tristan, and I'll give you mic privilege if you want to use it, you can. Okay, excellent. Tristan's given us an awesome start here. So he's saying start with the center point. So he identified that the coordinates here are 1, -3. Then he moved on to the radius. So from the center of the circle to the edge, the distance is 4. So he said the radius is 4. And then he's putting that into this equation here. Remember, the h value is the x value of the center. The k value is the y value of the center. So this is h and this is k. Excellent. Good. I love how you put that double parenthesis there, Tristan, because that's key. You really have to watch your signs here. I think that's going to be the trickiest part. So you have x minus 1 squared plus y minus -3 squared. And then a radius squared, so it'd be 4 squared. Excellent. Yep, and then just simplifying that. Here, let's see, I'll try to make this box a little bigger for you. There you go. Sorry, hopefully I didn't mess you up there. But yes, so you can see how over here I wrote 4 squared and Tristan wrote 16. Well, they're the same because 4 squared is 16. Okay. And then here, you guys can see in the chat, once you do the double negative here, you guys are all typing y plus 3, which is correct. Okay, does that make sense? Any questions on that? Thank you, Tristan, for putting that up on the board. Give Tristan a round of applause. Nice work. Are there any questions there? Okay, good, Safa. Safa says it makes sense. Aspen says no questions. Okay, cool. Okay, all right. Now, can I get a volunteer to graph this one for me? All right, Will is on top of it. Oh, so close. Thank you, Tristan. Yeah, I love all this. I love it when you guys jump on there. Okay, so William's going to try to graph this for us. It's basically just the opposite of what we just did. On the opposite one, we already had the graph and we wrote the equation. Now you have the equation, you're going to get the graph. This one's almost a little bit trickier. So remember, my tip for you a couple slides back was to watch your signs. Okay, 2 tips for you. Watch your signs here. And remember that this is not r, it's r squared over here, this number is. Okay? Good question, Will. So what you want to do, Tristan, sorry. Good question, Tristan. So what you want to do on this one is you want to take the number here and make it equal to r squared. So you have to do like a little mini algebra equation to find out what r is. Okay, so yeah, what they did, they didn't write it as r squared because they went ahead and simplified. They already did the squaring part of it. So I know you'll see that. Let me finish it, Tristan, and you'll see. But I know kind of your brain sort of stuck there. So what you're going to do is you're going to square root, and then you're going to find out that r is 2. So how they would, if you were going to write this, you could write it like this. I think this is what you're thinking of right now, Tristan. So let's see if this would make, you would write that as 2 squared. So 2 squared is the same as 4. Yeah, see, I knew that's what you're thinking. Yes, which is very common because it's kind of, you're going backwards and so your brain is stuck going forward instead of backwards, yeah. So that's what you want to do. If you have the equation to get r, take this number here and set it equal to r squared to make a little algebra equation out of it, and then square root, and you'll find r. Okay? Yeah, let's see. So another tip too. Okay, so with the signs, that's somewhere to get messed up. Let's take the x plus 1 and write it as a double negative. So I'd write that as x minus negative 1. So let's see, Stephanie says she thinks this would be in quadrant 2. Let's check. Okay, so this would be, does that make any sense to you guys? I'm taking the plus sign here and rewriting it as a double negative. And the reason I'm doing that is because in the equation there's a subtraction sign. And so I'm trying to get that to match. Okay, so, oh, okay, so yes, Ben, you're interpreting for Will. See, you guys are brothers. You know what you're thinking. Yes, I think you just flipped those around there, Will. That's right. So looks like Ben said it's -1, 3. So that makes sense to me. So -1 would be the h value and 3 would be the k value. So the center should be at -1, 3. So yeah, I think that's right, Will. You just flipped it. Yes, yes, which is not a big deal. And again, I love it when you guys do stuff like that in Class Connect because you're going to help everybody else to remember not to make that mistake. So yeah, just remember because it's x here that this one is the x coordinate, and then the one that is in the parentheses with the y is the y coordinate. Yeah, but it's easy to do. Otherwise, looks great. let's see. I don't even know if I might be able to just move it. Let's see if I can grab that whole thing. Oh, I don't know if I'm going to be able to. Let's see. I'll have to move them separately. So -1, let's move the point first. I'm going to move Will's point here. Oh, let's see if I can. Okay, so we're going to go -1, 3. There we go. And now we're going to put the circle around there. Does that look better? All right, I think that looks better. Thank you, Will. Give Will a round of applause. Nice job. Tristan's clapping loudly. Awesome. Okay, intercepts of a circle. So a circle can have up to 4 intercepts. So let's review what intercepts are. When we talk about intercepts, we're talking about where the graph crosses the x or the y axis. So remember when we had a line, so if we grab a line, say, okay, there's a purplish pinkish line, whatever color you want to, what color would you guys say that is? I'd say it's more purple than pink, but we'll just call it purple. All right, and we would say the x-intercept. Yes, good, Tristan. So it has 2 intercepts because it crosses the x-axis there and it crosses the y-axis there. And we would say the x-intercept is 3, the y-intercept is -3. Okay, or if I change, there you go, Delia, pink per. We created a new color. I like that. Violet, maybe that's what fuchsia, maybe that's what we should call it. Okay, if I move the line here, we'd say the y-intercept is -4. Okay, so do you guys recall that? Remember doing that for a line? Give me a smiley face if intercepts are coming back to you. Oh, nice, Tristan. Royal pink per. Nice. Okay, good. I'm glad that's making sense. We did go over that first semester, but I know that's been first semester, so that's why we review all that, and you did it also in algebra. All right, so same thing for a circle. You're going to have intercepts. You can have up to 4. Okay, so as this picture is showing, it's centered right at 0, 0. You have 2 y-intercepts and 2 x-intercepts for a total of 4 intercepts altogether. You might have just 3. As this picture is showing, you have 2 y-intercepts, 1 x-intercept. Okay. Yeah, that works, Delia. Yep, yep. Right, Tristan. Or, okay, I thought I had that on the slide, but I guess I don't. But you're right. So we could have up to 4, but you could have 3, you could have 2, or you could have 0. Excellent. Okay. You could even have 1 if it just touched. So for example, like if you picture this circle, now let's see if I can draw it. Let me switch to my circle tool if it will let me. So if I drew a circle and it just touched like right there. Okay. So that would be an example of 1 intercept. Okay? Yes, exactly. It'd have to be a tangent intercept. Good. I love that you guys are using that vocabulary. Awesome. Very good. X-axis would be tangent to that circle. Perfect. Nice, guys. So, yeah, exactly. So up to 4, but anything below that. Okay, so a max of 4, but it could have 4, 3, 2, 1, or none. Okay, so none would be like if the circle is just over here. Okay? So that's what we're talking about when we talk about intercepts. Now remember, okay, again, I'm always telling you guys to think in terms of analogy, right? So let's think back to a line. How did you find the x-intercept? Do you remember? So let's just make up an equation of line, see if this jogs your memory. So let's say I had y equals 2x plus 6. How would I find the x-intercept? Do you guys remember how to do that? Good, Tristan does. So make either x or y 0. Good. So in this case, and again, just think about what's going on the graph. So if you are trying to find your x-intercept, what is the y value? So x-intercept means it's going to cross the x-axis, what's the y value anywhere along there? What's the y value anywhere along the x-intercept? Like if you pick this point or this point, think about the coordinates. Good, Stephanie. Yeah, good, Tristan. It's going to be 0. So that was the key, is like if you're looking for the x-intercept, you make the y value 0. You plug 0 in right here for the y value, and you solve for x. So we would make a little algebra equation. 0 equals 2x plus 6. We'd subtract 6. Negative 6 equals 2x, divide by 2. And we would get x equals negative 3. Whew, barely fit that in down there. Okay? So we would have an x-intercept right here at negative 3, 0. Okay? So just remember, it's just going to be the same idea here. Okay? We have a different looking equation because now we're talking about circles, but the idea of intercepts is going to be the same. If you want to find the x-intercepts of this circle, plug in 0 for y and solve for x and see what you get. Or if you want to find the y-intercepts, do the opposite thing. Put 0 in here for x and find out what y would equal. Okay? Now, we do have, oh, and I forgot to give you guys this. Let me give polling to you. See if you can, if you get the idea, see if you can figure out which one it is. I forgot A, B, C, or D, but you guys can figure that out, right? So tell me A, B, C, or D, which one you think it is. The advantage here, you have multiple choice. And so another thing you could do, I'll show you how to do it this way, but another thing you could do is you can plug in these values. This is your x value, this is your y value, and you can see if that makes this true. And if it does, then that would be an intercept. Now, again, okay, use your test-taking skills. Do you need to probably plug in 0, 0? Why not? I'm just trying to, this is good to see for ACT. We started out talking about ACT. Michaela got us off on that tangent. We're going to go with that and talk about test-taking skills, okay? Because it's in every single answer, right? So it has to be 0, 0. 0, 0 has to be an intercept, okay? Yeah, that's what I was going for there, Tristan. Okay? But these others are different, okay? So definitely plug these in. Sorry about that, Nora. Oh, I think I spoke too soon. Nora was typing that in, and sorry about that. Okay? But I'll show you too how to, I know, you guys just need to jump on the mic because I get too impatient and then I give you the answer before you have a chance. So I'll show you how to do it if you didn't have multiple choice, okay? And then you guys can either use the advantage of multiple choice or not. But let's see, so Jennifer has her answer in already, awesome. And Tristan does too, so keep going, see if you guys can beat me here. I'm going to start with the x-intercept, and I'm going to plug y equals 0 in, okay? So if I do that, I would have x minus 5 squared plus 0 plus 12 squared equals 169. So on the left-hand side, I want to use, please excuse my dear Aunt Sally. I'm going to add 0 plus 12. Then I'm going to square 12. And then I'm going to subtract 144. And then here's where you might, it probably gets a little fuzzy. What you want to do is square root. And then that gives me just the x minus 5. Now, one thing you probably forgot, when you square root something, you actually have to add the plus or minus part out in front, because if you take negative 5 times negative 5, that also equals 25. Or positive 5 times positive 5 equals 25. So just a review there. Okay, and then I'm going to add 5 to each side of the equation. And here's where it starts to look a little bit funny. Now you have seen this before, I promise. In Algebra 1 you did this, but I know it's been a long time ago, so this starts to look a little strange. How you would write the answer is positive 5, which is coming from this one right here, plus or minus 5, which is coming from this part here. Okay? And that gives you two answers. One answer is the 5 plus 5 part, and one answer is the 5 minus 5 part. So you have 10 or 0. Okay? Now remember that how we got here was we plugged 0 in here for y. So this is actually giving you 2 points. These are the x values, and then the y values are 0. Okay, so you have the point 10, 0, and 0, 0. So let's see, Ashton said we could eliminate B and D. Yes, I would agree with that. Because, let's see, so B and C, sorry, B and C. So B, yeah, that's not gonna, that's the opposite way, 0, 10 instead of 10, 0. And this one is negative. Oh, and actually this one, that's not gonna be good either. So just by doing that, the x-intercepts, we can narrow it down to A. Now if we needed to, we could do the same thing, this same process, but plug 0 in for x and find y. But again, since we have multiple choice, we don't have to go that far. You could do it too if you weren't, like, oh, I think I did that right, but I'm not totally sure. You could, do it just to kind of confirm your answer. Okay. So I know that one was tricky. Right here, this is probably where you're like, what? I lost you. So I know there are probably questions out there about this one. I'm going to just briefly go over this again, okay, if you guys didn't catch that the first time. So up to this line, I think you guys are probably like, yeah, okay, I'm kind of with you there. What I did here was I subtracted 144, and that's where the 25 is coming from. Okay, and so remember, I subtracted 144, so all I had on the left was x minus 5 squared. Okay, so I have x minus 5 squared equals 25. The reason that you see the square roots here is that I'm trying to get rid of the exponent of 2. Okay, so I did accomplish that goal. I get just x minus 5 because the exponent of 2 and the square root cancel each other out. Here, the reason that there's a plus or minus sitting out in front here, if we square root, there are two things that could equal 25. This represents positive 5 times positive 5 can equal 25. But the other choice is that negative 5 times negative 5 could also equal 25, right? Because a negative times a negative is a positive. So that's why you want to put the plus or minus here. Then I want to get x by itself, so I added 5 so that these 5s cancel on the left. And then I also have to do the same thing on the right. And then I write 5 plus or minus, because the plus or minus is still here from the square root part of the problem, plus or minus 5. And that's where you get the two answers of 10 and 0. 5 plus 5 is 10. 5 minus 5 is 0. Okay? Does that clear up a little bit of confusion if you guys were lost? Is anyone still out there way confused? And that's okay if you are, because I know this has been a while ago. Okay. Well, let me know if you guys don't want to say anything in here. I understand. Don't be shy. We're kind to each other in here, but if you need to give me a call or send me a K-mail, come to tutor time next week. Do that, okay? All right, 4.14. What are the coordinates of the center of the circle that passes through the points 1, 1, 1, 5, and 5, 5? What we want to do here is we want to graph these points first, and then we'll be able to find the center of the circle in our radius so that we're able to write the equation. Now, we could also possibly just pick this up from the graph. So let's graph it first and see what happens. So I'm going to graph the 0.11. I'm going to graph the 0.15. And I'm going to graph the 0.55. Oh, thank you. You guys are helping me out. Okay. Okay. So how does that help me? Any ideas here? Yes. So yes, Tristan, that's the edge of the circle. Okay, so Ben says find the last point of the square that the points form and then find the center of the square. Okay, I like the direction you're going there, Ben. So let's see. Let me draw, see if I can draw a circle here to kind of get it to match up. This is a little challenging and illuminate. Oh, not too bad for my first try. Still a little off. Let's see if I can, not too bad, right? Okay, that gives you a little bit more of a visual there. Okay, so let's think about, let's see, so you need 5, 1, so let's see, 5. Okay, yes, you would also know that that's on the circle, right, the 0.51. How could you find the center of the circle? Because that's what we're going for. Any ideas on how to find the center? Yeah, I see somebody drew it in there. So visually, it looks like that's probably it, right? So 3, 3. Now, if you have drawn it to scale, and you could even grab your compass and put the center of your compass here and go around and actually draw a really accurate graph and figure out that it is 3, 3. And yes, that's right, Ben, it does just look right. Now, in this case, you know, you're probably good. But what you could also do is, you know that those 2 points are on the edge of the circle. So what have I just drawn? If I connect those 2 points, what have I drawn on the circle? Good, diameter. And you could find that distance, right? What would you use to find the length of that diameter? You could do that. Well, we have something that's actually probably not quite as involved as that would be. You could get there with the Pythagorean theorem. You could use a ruler, but only if Noor has a distance formula. You guys remember that? That's to find the distance between any 2 points, even if they're not perfectly horizontal or vertical from each other. Sort of. Hey, at least you're honest, Tristan. So here's the distance formula. In case you forgot, I think we're going to run out of time to actually complete it. If you do have to go, I understand. We just have 2 more slides. The last slide's extra credit, so if you guys can hang on just a second, I'll get you some extra credit. But here's the distance formula. Okay, and you might have x2 minus x1 or y2 minus y1. It really doesn't matter. You're just subtracting those values. So we could find the distance between these points, take half of it, and then use the distance formula again to confirm that that is the center. It comes from the Pythagorean theorem, yes. So that's what I was saying. You could get there from Pythagorean theorem. This will just get you there a little bit more directly and faster. But yeah, Pythagorean theorem would get you there too. But you guys are right. It is 3, 3. And so like I said, as long as your graph's accurate, then you can use, you know, that advantage, but also confirm it with the distance formula. I don't have time to go into all the details there. You'll also go over translations in 4.14. So remember, if we're going to translate 2 units right, remember that that affects your x value, right? So if you're going right, that would be affecting the x value going to the right 2. And then 3 units down. Down is a y direction, so we do y minus 3. So just think about, now, and also one thing you could do here, you have the equation, so you could even graph that circle, apply these transformations, and then see what the equation would turn out to be. Okay? Also think about it this way. If you're going to, if you already know, okay, this is the center point, 5 would be the x-coordinate of the center. If I want to move that center point 2 places to the right, I'm going to end up at 7. Right? So my center, let's pick out the center of the circle. If you have to go, you can. I'm going to try to finish this last slide really quickly, though. No problem, Ben. I love that. See you, Ben. Okay. And then remember, watch that sign. The y value is actually a minus 12. So if I apply the plus 2 part, if I go right 2, the center would move over to 7, and it would move down 3, so it'd be at minus 15. Okay? So that's actually going to match up with A. You wouldn't even have to mess with the radius, because just looking at your signs, this one is going to give you the center that we're looking for of 7, negative 15.